So what we're going to do with these two data sets, and this is a common skill that we have as chemists, we have data that we've collected from an experiment, and we need to fit that data. And what that means is that we're going to try to have an equation that, given the X values, predicts the Y values. Okay, so the data itself has X and Y data that you could graph, but then fitting it to an equation means that we have some line or curve that would go through the points of the graph. I'm sure you've had some experience with this because you've had to do labs before and you've had to make graphs and you'd have to put lines through the points, right? So you do have experience with this. What I think we will expand upon perhaps today is the use of a function in Excel called LINEST, which is a line estimation algorithm. And not only will it allow you to put a line through a set of points, but it will produce some other information about that line, the goodness of the fit. It'll give you plus or minus error on the slope and the intercept. And so this is the way we would treat data in Excel. So like I said, there are step-by-step procedure here to follow that you can start with the data that's already in Excel. It shows you here how to use the LINEST function. And then it gives you a interpretation of what comes out of LINEST. There are, let's see, 10 different numbers that come out of the LINEST, and they're all labeled here in the handout. The first two numbers are the slope and the intercept. Then in the second row, you have the error on the slope and the error on the intercept. And then in the other rows, you have data about the statistical fit. The second page of the handout shows the result of the LINEST. That's these numbers here, as I've just explained, slope and intercept, and the error on the slope and intercept. And then the graph that we want to produce. So this gives you a target for what the graph should look like. There can be some variability here. For instance, I don't care if you use blue triangles for the data points. You can use something else. But when you look at this graph, the thing that you want to focus on is see how the data is distributed across the entire graph pane. So it's not, all the data isn't clustered up in a corner, for instance. If that's the way your graph looks, you'll need to adjust the axes, because when we show graphs, we want the data to be spread through the full graph pane. We have the equation of the line on here, and we have the slope reported along with its error. Axes are labeled, and we have a title. And you can use different colors, different fonts. All of that is up to you. Try to be creative. Let's not have everyone submit the same graph. But the essential features, right, are that, things are properly labeled, that you can clearly see all the data, and then it's spread out throughout the whole graph. The second part, the second data set that I'll have you analyze today is not a linear data set. We wouldn't be able to put a line through the points here. The solubility of oxygen as a function of temperature is actually a curved line, and it can be fit to a power series. That equation is shown here. And what you can do in terms of fitting this, rather than only getting a slope and intercept, the LINEST function will give you all four of these coefficients, the A, the B, the C, and the D. So we can use LINEST to fit a power series. Solubility of oxygen is not linear, but it does fit very well to a power series. We don't know what A, B, C, and D are. The LINEST function gives it to us. So this is another way in which we can do data fitting. And the instructions there you can follow. In this case, we're going to need in our spreadsheet to have columns, not only for the temperature, but for the temperature squared and the temperature cubed, because those are the elements in the equation that we're going to be fitting. Before I let you loose on this, maybe just do the first part. You can watch me do it and then try it out on your own, and then ask me if you have any issues. So here we're starting with the first data set. And I'm going to skip ahead to the LINEST part because that's the part that may be a little bit new for some of you. If you've never used LINEST before, I'm going to demonstrate it. Here we have a data set that we want to fit using LINEST. And I'm going to start in cell A12. And I'm going to highlight, that means, hold down with the left mouse button and drag out until I've highlighted, let's say I need 5 rows and 2 columns. And this is a formula now that we're going to enter. It's a multi-cell formula. So this formula will fill out all of these cells in the table. And with any formula, you start with an equals sign so that it knows you're entering a formula and not just simple text. And then the LINEST function, L-I-N-E-S-T, line estimation. Notice as I was typing there, Excel expects, anticipates what I'm doing, and it actually showed me the LINEST function there in the just below where I'm entering the formula. And then it actually has a description of this. It says returns statistics that describe a linearized matching known data points. When I put the next thing, which is open paren, that's how you would enter parameters to a function, right? So I've typed LINEST and then open paren. When I do that, the little help below tells me what I should be filling in. It says known y's followed by known x's, and then something called a constant, and then something called stats. So 4 things I've got to fill in here. So the known y's come first. So that's the length here, because we got x-axis is going to have the mass, y-axis is going to have the length. So we want these values 5.1 to 9.4. You can either highlight those cells, or you could just say B2 colon B9. And it'll highlight it for you, comma. And now we need the x's, which is A2 colon A9. Now, comma. And there's 2 more things, constants and stats. And the constant says, do we want LINEST to compute the constant? That means the y-intercept. And yes, we do. So we're going to put true. Notice it also confirms that what this means. There's a little hint there. True means that B is calculated, comma, and then stats. Do we want stats? Yes, we want all the statistical analysis on this line fitting as well. True is the 4th item. And we're almost done here, but a critical step here is that because this is a multi-cell formula, I don't just want to hit enter because that'll only fill the A12. If I want to fill out the entire block here, I have to do shift control enter. So close paren and then shift control enter. And it fills out all of those numbers. And if you're, again, wondering what each of these numbers represent, the handout explains each item. The first is the slope, and then the intercept. And then in the second row, we have the error on the slope and the error on the intercept. And then the other things are related to the goodness of fit. So I'll let you try that out. But I wanted to demonstrate it first in case you hadn't seen LINEST before. Skipping ahead now to the data set 2. Here, if you follow the instructions, it explains how to do this. But again, I just want, in case you haven't used formulas before, I want to at least demonstrate it for you. We have the solubility. We have temperature, which is going to be on the x-axis, and the solubility on the y-axis. We already have a graph made of the experimental data. And what the analysis that you're doing is you're trying to fit the data. You want an equation and of a line. In this case, it's not a straight line, it's a curved line, but you want an equation of a curved line that goes through all of these points. And the equation is shown below, and the LINEST is going to give you the values of A, B, C, and D. But you have to give LINEST not only the temperature, but the temperature squared and the temperature cubed, because those are the elements in the equation. So if I wanted to put the temperature squared in this column B, I would use a formula again. I would say equals, and then I could type A4, that's the cell that has the temperature, and then a star for multiplication, A4. A4 star A4, hit enter. And then in cell C4, I would put equals A4. Actually, I could do something cute here, right? I could do equals B4, right, times A4. That would give me T cubed, wouldn't it? And I don't want to have to type that formula in 19 different times, right? So what I do is I highlight those two cells that I just created, and now carefully moving, without clicking on the mouse, I'm just moving the mouse until the cursor turns into a solid plus sign, solid black plus sign at the lower corner, the lower right corner. And then I can hold down with the left mouse button and drag. And that's how I fill down a set of cells and then release. And that will copy down. And everything's passed by reference, right? So now you see T squared of 5 is 25. T cubed of 5 is 125. All of the data is filled out. Looks like I missed the last one, but I can just extend it. There we go. Now I've got them all in there. The column here, we can't enter in yet until we do the LINEST, but you'll be able to do the LINEST and then enter a formula, because we're going to be using cells down here that are in the yellow area. When we refer to these cells, though, instead of just like for this one, A23, or for this one, B23, instead of using that, we're going to use $A and $B20 and $23. And that's because if you were to copy down the formula, we don't want those things to update. And so we put a little $sign in front. Let me show you what I mean. Suppose we wanted to reference the cell here, B6. I could say equals B6 over here to the right. And I've got my 100. And if I were to copy that down, of course, B6 becomes B7, becomes B8, becomes B. But if I didn't want that, suppose I wanted to always reference the cell B6. This is kind of like locking it. You could think of as locking it. I'm going to say $B, $6. And now when I copy down, it's always 100. Or if I can copy across as well, it's always 100. So if you want to reference a cell by its absolute contents and not have it be updated as you move, you have to use the dollar signs. And so when you reference these cells in the yellow boxes, you'll have to use dollar signs in the formula.